Good morning to all of you. Today we have studied the Thevenin equivalent circuit for the circuit which is consist of AC input as well as along with the capacitor and inductive components. Now, whenever we have to use the inductive and capacitive component, these values are represented in terms of rectangular form or polar form. Polar form in the sense that if the quantity is represented like this, means value magnitude along with the uh, angle, in that case we have to say that this value it is in terms of polar form. And if you are representing the quantity in terms of j minus j like that, in that case it is represented in terms of rectangular form. Now for this case, for this circuit, we have to obtain the Thevenin equivalent circuit. Now, why this negative sign and why this is positive sign? Because it is inductor, and in case of inductor, the current lags behind the voltage by 90 degree. Therefore, it is the positive term, and for the capacitor, current leads means current leads the voltage by 90 degree. Therefore, this quantity is represented as negative field. Now we have to find out the Thevenin equivalent voltage and Thevenin equivalent resistance. For that purpose, we have to apply our same method, and these same methods, that is step one, we have to calculate open circuit voltage or open terminal voltage which is obtained between terminals A and B. To calculate Thevenin equivalent voltage VTH, disconnect load impedance, means here it is that load impedance. Which type of impedance it is? It is a resistor, but we have to represent with only ZL value, that is 10 with angle 0, because in case of resistor the current and voltage are in phase with each other. Therefore the angle value should be 0. Now here we have to disconnect the load impedance if any, and the circuit becomes, in circuit should be looks like this. Now for the circuit we have to find out the current. Now current which is flowing through the circuit, now the here that current must be flowing like this. Means in this case the circuit should be current should be flowing like this. Now here between this J10, that is for this inductor, there is no current, and therefore the voltage across this J5, that is voltage across this capacitor, it is nothing but our Thevenin equivalent voltage. Now to calculate that voltage we have to use, or we have to firstly calculate the current value. Now the first I have to write, that is current flowing through the circuit. Here it is current flowing through the circuit, through the circuit. I is equal to, what is I? It is nothing but voltage divided by resistance. But in this case, it is not only voltage divided by resistance, but here the capacitive reactance should be also present. The inductive reactance should be also present. Therefore, we have to write the total reactance value, that is Z. Now, what is that quantity? That voltage, it is 10 with angle 0, and the Z value, it is nothing but resistance and this capacitor, and therefore its value should be 10 minus J5. Now these two quantities are in different format. One it is in polar format while other it is in rectangular form, and therefore it is necessary to convert these quantities into required format. Either you have to convert into polar format, or you have to convert these values in rectangular format. And therefore, to how to convert, firstly I have to give you just one example, that is this quantity we have to convert into polar form like this. Now here I have to mention that that is magnitude and angle value. That values are required in terms of polar format. That is m is, it is nothing but x square plus y square. What is that x? Here it is that 10 value, it is represented as x, and this 5 value it is represented as a y. Now it is that square root of 10 square plus 5 square, that is square root of 125, and its value should be represented as 11.18. Now the another quantity that we have to require, that is nothing but theta, that is angle, which is nothing but tan inverse of y upon x. Now how it is represented, that is tan inverse of, it is 5 value y and 10 value for x, and therefore its value should be tan inverse of 0.5. And if you are calculating the tan inverse for the 0.5 value, in that case its value angle should be theta equal to, becomes as a 26.56. Now we have to obtain both quantities, that is magnitude value should be also obtained, and the angle value should be also obtained, and therefore I have to write this quantity as 10 divided by 10 with angle 0 divided by 11.18 with angle 26.56. Now, why these quantities are required to convert into polar format? Because whenever we have to use the division and multiplication operation, it is better to get the quantity or simplified with polar format. And if you are required addition and subtraction, in that case, you have to use the rectangular form. Now here, how it is solved? It is nothing. It is easily solved. That is 10 divided by this quantity. And for this angle value, what is they required? That is they are making the subtraction between one another. That is 11.18 and with angle 0 minus 26.56. Now these values, it should be represented as I equal to 0.895 with angle, that is here it is minus because as it is negative, and this quantity it is again minus, therefore it becomes plus, that is 26.56. Now here we have to obtain the current value for this case, and the current value, it is represented like this: current flowing through the circuit that we have to obtain. Now we have to calculate Thevenin equivalent voltage, that is VTH. It is nothing but voltage across this capacitor, because no current flowing through this inductor value, that is 10 J10, and therefore it is open circuit voltage which is obtained across this capacitor. That is Thevenin equivalent voltage. Now this Thevenin equivalent voltage, it is represented as VTH equal to, that is I into J minus J5. Now what is I? It is nothing but 0.895 with angle 26.56 into, now this quantity we have to convert again into our angular format, that is theta and magnitude format. And if you are converting this value in terms of theta and magnitude, then it is represented as 5 with the angle, that is minus 90 degree, and it is that minus 90 degree, it is for the capacitor. And if you are considering the inductor, its value should be plus. Now we have to solve this. Now these two quantities are multiplied, and these two quantities we have to add. Means here that value is 0.895 into 5 with angle 26.56 in plus, here it is minus 90 degree, and therefore this quantity, it is represented like this, that is 4.47 with angle minus 63.44. Means if these values are subtracted, and we have to get this value, that is VTA. Means we have to obtain the first quantity, that is Thevenin equivalent voltage. Here it is that Thevenin equivalent voltage should be obtained. Now, step second, that is we have to obtain the Thevenin equivalent resistance for this case. Now, how it is obtained? We have to initially again use step second. What is the step second? Here it is the step second. To calculate Thevenin equivalent resistance, replace all voltage source, all voltage source by short circuit and current source by current source by open circuit, remaining their internal resistance, remaining their internal resistance, if any, resistance if any. Means in this case there is again no resistance, and therefore we cannot think about this resistance value. Then the circuit must be simplified as here it is looks like this. It is 10 ohm resistor. Then here the inductance coil, which is value should be J10, and the capacitor it is having the value minus J5, and these terminals are represented like this: A terminal and B terminal. Now we have to find out the resistance value, that is RTH must be obtained from this side. RTH must be obtained from this side, means we have to see the resistance value or calculate from the A terminal and end at the B terminal. Now in last time also I have given that is for Thevenin equivalent voltage or Norton equivalent, Thevenin equivalent resistance and Norton equivalent resistance. Both are same, and in that case what we have to do, we have to implement the similar procedure here also. That is, you have to put one resistor in upward direction, or one terminal in upward direction, and automatically the another terminal should be becomes towards lower end, and you have to get the series as well as parallel combination. Now how to get this? Here I have to put that is one A terminal, and it is started with the inductor coil. I have to put here. Now here it is that inductor coil. Then I have to come here. Here there are two paths. Means here it is the way of simplification. In whenever you have to get the simplified form, you can calculate resistance, impedance of the circuit immediately. It is not necessary. Sorry, here I have to, instead of resistance, it is impedance. And here it is the capacitor. Now these two terminals are come at this point, and finally it is come at the another point, that is B terminal. Means here it is 10 ohm and minus J5. Here it is J10. Now which are the series combination? Which are the parallel combination? Here it is J10. It is in series with the parallel combination of this resistance and capacitor. Now we have to find out ZTH, that is Thevenin equivalent resistance, that is ZTH, like this. Here it is J10 plus parallel combination of J minus J5 in parallel with 10 ohm, 10 ohm with that is 0 degree. Means here we have to make the simplification. Now here J10 plus, now it is only 10 value should be remaining. here 10 into minus j5 upon 10 plus, sorry, 10 minus it is j5, because the plus sign it is replaced with this minus sign of j. Now the next term, that is we have to again simplify these two quantities. Then for the simplification of these two quantities, we have to convert into required, that is j10 plus 10 with angle 0. That is I have earlier mentioned here also. That is, now for this j5 we have to make the multiplication, that is 5, 5 with magnitude, and the angle should be minus 90 degrees. It is also for the capacitor. Means as the capacitor it is present, we have to use the negative sign. Upon this quantity, it is as it is 10 minus j5. That is the quantity, it is in terms of rectangular form. Now this j10 plus these quantities are multiplied, that is magnitude should be multiplied 10 into 5, it becomes 50 with the angle, that is addition of these two angles, that is 0 minus 90, that is it gives again minus 90 degree, upon 10 minus j5. Now here this quantity again we have to convert into the polar format, like this, and here this polar format for this 10 minus j5, that is we have to find out earlier in this case, that is here also 10 minus j5, and it is represented as a 11 point, 11 point minus sorry 11.18 with angle minus 26.56. I have to write the same value, that is here it is j10 plus 50 with angle minus 90 degree upon 11.18 with angle minus 26.56. Now this uh, division 50 divided by 11.18 and this angle are subtracted from one another. That is, this quantity is subtracted from this. Now here we have to represent that is J10 plus 50 divided by this 11.18 with angle, that is minus 90 minus minus 26.56. Now, whatever the quantity we have to obtain, that is again the negative quantity, because the 90 degree is more term, that is J10 plus here this value should be become as a 4.472 with the angle minus 63.44. Now this quantity is obtained, that is JPH. Now again it is not in the required format. We have to convert this quantity into polar format. That is, it is converted like this. That is J10. It is nothing but 10 with angle plus 90 degree. Now the summation of this quantity is not easily obtained. Therefore, we have to convert this quantity into another format, that is polar format. That is, we have to make this cancel. That is J10 plus 2 into 2 minus J4 it is. Now this quantity we have to obtain with the method of, that is reverse method, which is earlier we have to obtain for magnitude and the theta value. Now here we have to find out the value of x and y by putting this theta magnitude value and x theta value, that is angle value. Now for the, we have to take the summation, and therefore this the values, that is 2, it is remains as it is, plus this j polar quantity, and this is another that is taken, and we have to get, that is plus j, which is having the value, that is nothing but j6 it is. Now if you want to represent this quantity in terms of the polar format, that is represented as 6.32 with angle 71.57. Now, if you want to calculate this quantity from this quantity, it is obtained with the again formula, that is m equal to square root of x square plus y square. Means we have to make the square value of the 2 square plus 6 square, and we have to get, that is 4 plus 36, that is square root of 40, and square root of 40 it becomes as 6.32. Now the theta value it is represented as a tan inverse of y upon x, and its value should be tan inverse y it is 6, y it is the 6 quantity, and x it is the 2 quantity, and therefore tan inverse of 3, tan inverse of 3, that gives, sorry, tan inverse of 3, it gives the value, that is 71.57. Now we have to obtain Thevenin equivalent voltage as well as Thevenin equivalent resistance. That is, here Z value should be obtained, ZTH, and we have to obtain Thevenin equivalent voltage. From these two, we have to write the simplified equation, and the simplified equation it is represented like this. That is step 3. To using VTH and ZTH, the equivalent circuit is as shown below. Here it is Thevenin equivalent voltage, that is VTH. What is the value of VTH? It is approximately the 4.47 with angle minus 63.44. Now here the ZTH I have to write directive block, because it is the combination of both the quantities, that is angle format, and with some reactive components should be present. Therefore, I have to write 57 ZTH. Here it is VTH, and the J in load resistance or load impedance. What is the load impedance value? That is ZL equal to 10, and it can be also represented as a 10 with 0 angles. Now for this circuit, we have to obtain the equivalent, current flowing through the circuit, and for this current flowing through the circuit, we have to write, that is IL equal to VTH, that is Thevenin equivalent voltage, divided by ZTH plus ZL, that is the impedance values. Now these quantities, that is 4.47 with angle minus 63.44 upon ZL plus J. Now these quantities required in the same format, so that the addition should be take place. Now for the addition, we have to require the quantities in terms of the in terms of that rectangular form, and that rectangular form for the JTH, it is we have to earlier represented as a 2 plus J6 plus. Now for this 10, this quantity, it is simply represented as a 10 because it is the resistive component. Means here it is not necessary to remember which type of component it is. Only J term should be occurs, positive J inductive component, negative J capacitive component. Now the summation, that is 4.47 with angle 63.44 divided by 10 plus 2, that is 12, plus J6. Now these quantities again required, this quantity must be represented in terms like this, that is polar format, and it is obtained with, that is m equal to square root of x square plus y square and theta equal to tan inverse of y upon x. Means by using this formula, you have to find out that quantity. Now I have to not making the simplification, because 12 square plus 6 square, that is 144 plus 36, means its value should be increases up to that 140 160, and therefore we have to make the simplified value, which is nothing but its value should be becomes as a 13.41, means it 4.47 with angle minus 63.44 upon this magnitude should be 13.41. And what is the angle? Angle should be again 6 divided by 12, and its value should be 26.56. Now here, as it is positive sign, here also the positive sign. Now the division from these two quantities, and here this angle it is subtracted from this. Now this value should be represented as 0.333 with angle, that is minus 63.44 minus 26.56, and it is represented as 0.33 with angle minus 90 degree, means here it is in the Z value, means the current flowing through the circuit. Now this current flowing through the circuit, it is depends upon the capacitive component, and therefore the negative sign must be present in the circuit. Now this is the AC analysis of Thevenin circuit. If you want to go towards the Norton, it should be also applicable. Now we have to stop here. Thank you for watching this video.